In today's video, we are going to learn about a concept called method overloading and also how to deconstruct a larger method. Let's first begin with method overloading. Method overloading is the process of using the same name for multiple methods. Now you might be wondering, well, why the heck would you do that? Well, sometimes the same method name, that same purpose could be done in different ways. So what we do is we use a different signature so that way the compiler knows which method that you want to invoke. And the signature of a method is the number of parameters, type, and the order of the parameters. It's very important to note that the return type is not part of the signature. So in order for methods to be considered different and to be overloaded, they have to have a different parameter list. And you can't just change the name of the parameter. It actually needs to be a different data type or different quantity of parameters. And what's going to happen is the compiler will determine which version of the method to call by analyzing that parameter list. So to show you an example of overloading methods, here I have two different methods. They are both called try_me, and they have different parameter lists. So the first version of try_me takes one integer, and the second version of try_me takes two parameters, an int and a double. And when the method is actually invoked, that means when it's called, what happens is the compiler looks at the parameter list. And in this case, since the parameter list has two parameters, the compiler knows that it needs to use version 2 of the try_me method. If I would have said, for example, result equals try_me and then just had one number, then the compiler would know to use this version of the try_me method. An example of an overloaded method that we have used quite a bit is the println method. If you think about it, when we've used the println method, we have used it for printing strings, integers, doubles. We've printed all kinds of things, but we haven't had to call it differently. So essentially what happens is that there are multiple ways that we can call the println method, and depending upon what parameter the user passes in will determine which version of the println method is called. So this makes it a very seamless process for the person using the method. Wouldn't it be annoying if we had to use print string, print int, print double? That would be quite frustrating. So that's why the method is overloaded, so that way we can use print or println to display anything. And when it's actually called, the different versions of the println method are called without us even having to do anything. Another example of when methods are overloaded is with our constructors. And this is a very useful thing for us to do because we want to provide multiple ways to initialize a new object. One of the things that we've seen already is the default constructor, and the default constructor takes no parameters. In our default constructor, we are essentially going to set numbers equal to 0 and set strings equal to quote quote. This essentially sets the stage like a blank template. However, it often makes more sense for us to create our objects with parameters passed in. So for that reason, we can have overloaded constructors, which give us a variety of ways of creating our new objects. So if you refer back to the bank account class that we made earlier in the year, if I were to create multiple constructors, then that would give me multiple ways to create bank accounts. In this first way, I am initializing a bank account only by providing the balance. So this bank account name would still be quote quote, it would have a default name. Now this second way that I'm creating a bank account object, I am passing in a name and a balance. So in this case, I have initialized both of those instance variables. So just to quick summarize, we have 3 different ways in this example that we could create bank account objects. The first way is the default constructor, where the balance would be equal to 0 and name would be quote quote. The second way is a constructor which allows us to specify the balance. So in this case, the name is still quote quote. The third way allows us to specify the name and the balance. So name would be bills and the balance would be $150. Depending upon your needs would determine which constructor you would use when building the object. The last thing that we're going to focus on today is something called method decomposition. So method decomposition is taking a potentially large method and breaking it up into several smaller methods for clarity. This can be helpful because sometimes, especially if you're working on a team, different members would be in charge of different tasks, and so you could make smaller methods that are all comprised together to get the job done. It also makes your code more readable when it's kind of treated like a bullet list. If we think back to our Bill lab that we did for Fremd After Dark, we had a large method called calculate bill. Well, we could break that up into several tasks. Task 1 is calculate the room cost. Task 2 is calculate catering. Then we calculate our discount, and so forth. So we could have smaller helper methods, and those helper methods are what we call support methods. Now, typically our support methods would have private visibility, and the reason why is because the user in the driver program would never call the calculate room or calculate catering method. The user would simply call calculate bill. And then these other methods are going to be used by calculate bill to kind of help farm out the work, so that way other people are doing the jobs for you. So we would call a service method would be public, and that service method may call one or more support methods to help it. So in this case, the calculate bill is the service method. That is the method of the class, okay? So this is the method that has public visibility. And then the other ones, these are your private methods because they are only going to be called within a public method. And so this further leads to that idea of encapsulation, that need to know. The driver program does not need to know everything that goes into calculating a bill. They just need to know that I want to take care of the task of calculating a bill, and then poof, it'll magically get done for us. All right, that's it for today. Thank you.